Hi everyone, I'm Rachan TM, studying in Sri Venkateswara College of Engineering, Bangalore, subject DMS, topic Basic Connectives and Truth Tables, Logical Equivalence. Introduction to Basic Connectives. Basic connectives are fundamental components in logic and mathematics. They help in forming complex logical expressions from simple propositions. Understanding these connectives is essential for evaluating logical statements. Logical connectives form the foundation of mathematical logic, computer science, and digital circuit design. They help in constructing component statements and understanding logical reasoning. Types of basic connectives: conjunction, and the conjunction is true only when both propositions is connected are true. The truth table of conjunction demonstrates this relationship clearly. Disjunction or the disjunction connective is symbolized by V. Disconjunction is true if at least one of proposition is true. This means that it can be true in the three scenarios: one true, both true, or at least one true. Negation not. Negation is the true value of proposition. If true, it becomes false and vice versa. Understanding negation is crucial for evaluating complex logical expressions. Implication if then. An implication is false only when the first proposition is true and the second is false. The connective is essential arguments and logical reasoning. Biconditional if and only if. It is true when both propositions have the same truth value, either both true or false. This connective is useful expressing equivalence between propositions. Negation, conjunction, disconjunction, biconjunction. Read not and or if then if and only if. Symbolic form between P and symbols. Truth table. A truth table is a mathematical table used to determine the truth value of logical expressions based on all possible truth value of its variables. Purpose of truth tables: to determine a logical statement is true or false for all combinations of truth values, to test the validity of logical arguments, to check if statements are tautological contradiction or logical equivalent, widely used in computer science, electrical engineering, and mathematical logic, to test the validity of logical arguments, and to tautology, contradiction, or logical equivalent. Truth table for basic connectives. Logical equivalence. Two logical statements are said to be logically equivalent if they have the same truth value in every position in every possible situation. In other words, their truth tables are identical. We denote logical equivalence by the symbol reads as P is logically equivalent to Q. Common logical operations include and, or, not, implies, and biconditional. Used in digital circuit design and computer programming, important in mathematical proofs and reasoning. Examples: the statements A and B and B and A are logically equivalent due to commutative property of and. The expressions not A or B and not A and B, not A and not B illustrate De Morgan's law, showing another form of equivalence. A implies B is logically equivalent to not A or B, which can simplify complex expressions. Common logical equivalence rules. Equivalence rules like commutative, associative, and distributive property are commonly used in logical expressions. Understanding the rules aids in transforming and amplifying logical statements effectively. The double negation law that law, the double negation law states not A is equivalent to A, like commutative, associative, and distributive properties are commonly used in logical expressions. Understanding these rules aids in transforming and simplifying logical statements effectively.